Seeking English, S.A.T. Workbook, page 317, problem 1. Before we start with this problem, I want to talk about two types of multiples that are going to come up in this problem and other problems. Teachers use different kinds of terminology. I try to use the terminology that I think is going to be useful to my students trying to get additional points on specific tests, and so far that has gone really well. So I'm going to stick with it. Two types of multiples we're going to talk about. I'm going to talk about tax multiple and discount multiple. If this sounds obvious to you, great. But it ends up not seeming obvious to many students during a test. So I have to make it more obvious. Okay. A tax discount, wow, I'm doing one take. A tax multiple is larger than 1. Okay? When you multiply a positive number by a tax multiple, it makes that thing larger. Okay? A discount multiple is smaller than 1. When you multiply a positive number by a discount multiple, it makes that thing smaller. The reason I use this terminology is not only for money problems on these tests. I use it for other types of things. You'll see eventually there's a radioactive decay problem, and there's a problem involving the heights of mountains. Why would I use it for that? Well, people care about money. So most people watching this video have paid a tax and they have received a discount. So they have the experience of seeing these things applied and possibly directly applying it. So money seems to be important to a lot of people, so that's the terminology I use, even if it's not money. In problem 1 on page 317, it is going to be money. But before I get there, the way that you get your tax multiple is you take the number 1 and you add the tax to it, the tax rate. If it's a 10% tax rate, you add 10% to 1. You get 1.1. Becomes your tax multiple. This is the best way to think about taxes on a test, and the best way to think about discounts on the test. Discounts are different. They're not as intuitively obvious. When they give you the discount rate, okay, you have to subtract the discount. Okay? So if I'm not going to say it's, I'm going to say 20%. If they have a 20% tax, okay, it's going to be 1 plus 20%, becomes 1.2, becomes your tax multiple. If they have a 20% discount, what do? You subtract, you divide? No, you don't subtract, you don't divide. It gets smaller through multiplication of a number smaller than 1. And you do that, it's 1 minus 20%, becomes 0.8. Okay? There. That's a 20% discount. Okay? So, that said, let's then look at this problem. Oof, a lot of words. Dave bought a new tennis racket at a shop that gave him a 30% discount off the original price. So right away you should be thinking, what am I going to do with the 30%? The 30% comes off of 100% to produce a discount rate. Okay, a discount multiple of 70%. Whatever the thing was, you're going to multiply it by 70%. Not 30%, not 130%. You're not going to subtract. It's a multiplication of 70% off the original price. The total amount he paid was R dollars, including a 9% sales tax on the discounted price of the racket. That's a little bit easier. In that case, you should be thinking, I'm going to add 0.9, which is 9% to 1.00, which is 100%. You get 109% or 1.09 is your tax multiple. Okay. Which of the following represents the original? Okay. An advantage. There are other more complicated ways to do this, and believe me, if you think this is complicated, you have not looked at them. An advantage to using this multiple system is that you can multiply things in either order, and you'll get the same result. If you take its original price and you multiply it by 1.09, and then you multiply it by 0.7, you'll get the same result if you multiply it the other way. Not everything works that way. And there are many things that go wrong, and in the later problems I'll show you. I know this is getting to be a longer than 5-minute video, But this thing here that I showed you, as specifically pertains to this first pertinent problem, is something that I want you to see in one video. I want you to see it in one video so it sticks a little bit better. I don't want it to be completely abstract. Okay, answers are. Question was, which of the following represents the original price of the racket in terms of R? I'm going to get those on the screen. Answer A, 0.79 R. Okay? Can you see what's wrong with that already? Okay, I'm getting ahead of myself. B is R over 0.79. C is R over 0.7 times 1.09. Okay? D is 0.7 and 1.09 times R. Okay. So what's wrong with each of these? Well, one thing is if you multiply the tax with the discount before you apply it to the price, which in this case you have to do because they don't give you the price, we're not going to get 0.79. Okay? The problem says no calculator. So you want to run 0.7 and 1.09 through your calculator. I don't recall having done that. I don't think this is the number you're going to get. Otherwise, this book needs a little revision. But no, I'm pretty sure that's not the correct answer for that reason. You see the same number down here. It's not a result of multiplying those two things together. So those are wrong right away. It goes immediately. So here you see the correct things. Here's your discount multiple, and there's your tax multiple. Now here, what are they asking for? It says, what was the original price? The original price is not the result of multiplying the original price by two things. We get two different numbers. The original price is a result of reversing the process. Okay, so if you take the original price R and you multiply it by these things, you don't get the original price. You get you get the new price. So R is what he actually paid. So you want to reverse the multiplication process by dividing it by these things. And you don't have to do the math. Don't waste your time on the test proving things to yourself. Okay? Once you've eliminated three answers, you don't need to prove to yourself that the fourth answer is correct. You can't really do that here because they don't give you any numbers. All you have to do is figure out what's wrong with these other three problems. Okay? These two don't include the multiples I indicated. This one down here has the correct multiples, but it shows the process, or it tells the story backwards. Okay. If you're still confused, I don't think what I have told you is necessarily confusing. You might just need to watch the video again. I know for a lot of people watching this, isn't this too obvious? Yeah, everyone says it's obvious, and yet somehow, when I run them through problems that they should be able to do, they end up not doing them. Is it due to mental fatigue? Possibly. But being more sure of things in advance is a way of working through or around mental fatigue or compensating for it. If something that's easy becomes hard, maybe it just wasn't easy enough in the first place. Make it easy. Make it obvious to yourself. Watch the video again if anything was in any way unclear to you. Also, I think we have a format currently where there's a comment section, and you can comment there if you need additional help. Thank you.